So today, for what it's worth, I'm going to talk about the geometric definition, whether you care about that or not. I care about it. We're going to talk about it. And of course, equations, how to graph them. And I'm going to talk about the eccentricity, is how you say that word, eccentricity of an ellipse. Basically, how round or oval it is. So here is a very lovely computer-generated picture of an ellipse, not my hand-drawn skills. So today, you're going to have two foci, not just a single focus. Focus is on parallel. You have two foci on your ellipse. Technically, because you've got to be technical, how an ellipse is generated, if you pick a point and you calculate the distance to each focus point and you add those together, you obviously will get some total. You can pick any other point on the ellipse, do the same thing, calculate the distance to each focus, and those totals are always going to match. It's always going to be the same thing. That is technically how an ellipse is generated. Now, let's be honest. Is that really going to matter to us as far as drawing them today? No. Probably not. Okay, now, this looks crazy, but I promise it's easy. I'm going to break it down for you. Don't forget the equations are in your graphing calculator too. Now, you are going to have two fractions today. They're going to be added up. They're going to equal 1. Hyperbolas, when we get to the fourth figure, are going to look very similar. Ellipse plus between them, hyperbola will have a minus. Now notice that a squared switches locations. A squared's under x in the first equation, a squared's under y in the second. I don't get crazy, you know I don't like to get crazy about formulas. Just a squared's the larger number always, so that's what makes it what we call a horizontal ellipse. It's wider than it is tall. This is a vertical ellipse. The larger denominator's under y, up and down. That's what makes it be a vertical ellipse. I'm going to show you how to do all the vertices. It's super easy, the lengths, all that good stuff. Other thing we have to get those foci, we got to know our equation. So that is not in your graphing calculator. You are going to have to memorize or know c squared equals a squared minus b squared. Now again, a lot of the equations and whatnot are going to be similar to hyperbolas. How I remember it, whatever you have for in your equation for a sine, plus, the foci has the opposite, minus. So when I do hyperbolas, it's going to be minus in the equation, but plus in the foci. So you always have the opposite in sine. That's an easy way I remember that. All right, so to draw these, here's the breakdown, okay? Let's say you have 36 under x squared. Well, what's the square root of 36? 6. A is 6. I go 6 right, 6 left. Let's say you have 4 under y squared. What's the square root of 4? 2 under y, so 2 up, 2 down. Bam, draw. So easy, except my drawing skills. All right, let's try one. Now, I gave you one to start off with. The center is at 0, 0. How I know that? You look at the numbers with x and y. Just like circles, just like parabolas. I look at what's with x and y, in our case 0, 0, so I don't have to worry about switching signs and parentheses or anything like that. Now, easy enough. 9 technically is a squared. Again, I don't even be like, ooh, what's a squared, what's b squared? Who cares? 9's under x. I'm going to square root 9. Square root of 9 is what? 3. So we're going to get technical. A is 3. I'm going to go, it's under x, 3 right, 3 left. 4 is under y squared. What's the square root of 4? 2. Under y, 2 up, 2 down. And I'm going to try to draw an oval around this. Good. Okay. The rest of this is super easy too. Now, the vertices, because you have 4 points on your ellipse. We have the left and right, the up and down. The vertices are the endpoints of the major axis, the longest axis. Our ellipse is horizontal because it's wider than it is tall. So these endpoints are the vertices. Now, do I care if you write V next to them on the homework? No, but I'm just doing it for dramatic effect. So my right one's at 3, 0, left negative 3, 0. You could put plus or minus 3 too if you'd like.
Are those ever going to be like
No. Length of the major axis, how wide is it? 6. We went 3 left, 3 right, total of 6. And then the minor axis, of course, is the shorter one, the up and down on this one. We went 2 up, 2 down, so 4. Now, last thing we have to do, and you've got to do a little math on this. To get the foci, it's the c squared equation. And, of course, plus in our equation, so our foci is minus. Now, common sense, I'm not going to be like, oh, what's a squared, what's b squared, do I do 9 minus 4 or 4 minus 9? Well, you're subtracting. It has to be a positive number. So I'm going to have to do 9 minus 4. If you do 4 minus 9, you get a negative. That's a no-go. All right, 9 minus 4 is 5. And then we're going to root it. Okay, plus or minus square root of 5. Now, I'm going to plot those on the graph to show you where they're at. So I put square root of 5 in my calculator to get a decimal approximation. It's about 2.2. So the foci are on the major axis, which ours is horizontal because our, of course, 9 under x made that the bigger one. So from my center, I'm going to go right 2.2, I'll park it, and left 2.2. And then I'm going to write those exact ordered pairs over there. I'm not going to use 2.2. I went left a square root of 5 and right a square root of 5. So I'm going to put plus or minus square root of 5, and then we're at 0 for the y coordinate. So that's the only, still easier than fabulous if you ask me. The only kind of yuck part is sometimes you do get these square roots for c, and you do need to use those exact square roots when you give the ordered pairs of the points. That's the worst thing you got today. I love an ellipse. Okay, not quite in the standard form, but we're going to get this one in there pretty easily. Don't worry, you're not completing the square yet. So, standard form. I need it set equal to 1, and I need fractions. Oh, okay, all right. Well, we can handle that. Set it equal to 1. I'm just going to divide by 144. But of course, I got to do to everything, and there's going to be my fractions. So you might need your calculators. I'm guessing we can't reduce 16 over 144 in our head. Not judging on that one. Let's reduce it. What's 16 over 144? 1/9. I'm not going to write the 1 though. What's 9 over 144? 1/16. I'm just not going to write the 1. And then of course there we are equal to 1. Okay, center, 0, 0 again. There's no numbers with x and y. We will get off of the origin here in a minute. Now, 9 is under x. I'm going to square root that, 3. So 3 right, 3 left, because that's what's under x. 16 is under y. What's the square root of 16? 4. So under y. So you're going 4 up, 4 down. So this is a vertical ellipse because it's taller than it is wide. Hey, man, that's one of my better drawn ones. Proud of that one.
Nice job.
Thanks. All right, vertices. So the question, next question, are the vertices the left and right points or the top and bottom? Top and bottom because they're on the major axes. So top point I'm at 0, 4, 0, negative 4. And you can combine that with plus or minus 4 if you want. What is the total length of your major axis? 8, 4 and 4, 8. So then what's the width? What's the length of the minor axis? 6. And this is, you know, the only real work we have to do today is the darn foci. So I'm going to do my c squared. Again, I'm not going to be like, oh my gosh, should I do 9 minus 16 or 16 minus 9? Common sense, we have to do which way? 16 minus 9, so we don't get a negative. What is 16 minus 9? Okay, so square root of 7. I forgot, I punched it in earlier. It's about 2.6, just for the record. So that's going to be on your major axis. So from the center, because our major axis this time is vertical, I'm going to go up 2.6, down 2.6. Exact ordered pairs. Those blue points, the x coordinates are at 0. I went up a square root of 7, and I went down a square root of 7. I'm just going to do the plus or minus for it. That's the worst thing you have are some of those radicals to deal with today for the foci. Any questions on this one? All right, love it, know it. Okay, in the form, nothing crazy, but what's your center?
1, 5.
1, 5. I'm just going to jot that down. You can just plot it, but I'm going to write it. Okay, so 1, 5, because you have values with x and y, just like circles. For all the figures, anything in parentheses, you got to switch the sign. 1, 5, got it. Mark it out the same, nothing exciting here. 9 is under x, I'm going to square root 9, 3. So 3 right from your new center and 3 left. 25's under y. Well, what's square root of 25? 5. So 5 up, 5 down from the center. 1, 2, 3, 4. Okay. So we've got a vertical ellipse, which I knew right away because your larger denominator was a y. So vertices, since it's vertical, of course, are our top and bottom points. We're at 1, 10 and 1, 0. What is the length of your major axis? 10. 5 up, 5 down, total of 10. Minor, how wide? 6. 3 left, 3 right. And now we're going to do some work. Okay, foci, our c squared equation. Now, again, I'm not going to be like, oh my gosh, like, well, a squared, b squared, which is it? No, common sense. We're going to subtract. I'm going to have to start with the 25 minus 9. Oh, I like this one. What's 25 minus 9? Hey, square root of 16 comes out nice, plus or minus 4. Okay, so from our center, I'm going to put these on our major axis, which is vertical. So up 4, down 4. And then, of course, I'm going to jot down those ordered pairs. So I'm at 1, 1, and I'm at 1, 9. 1, 1, 1, 9. So that is how to handle it if you are not on the origin for the center. Same thing. Any questions on that? Okay. Love an ellipse. Okay, last thing I have for you, just one more thing to add on. We like to know the eccentricity of an ellipse, which basically kind of gives you an idea of how elongated it is versus how it's a little bit maybe more on the circular side. Anytime your eccentricity is closer to 1, it's more elongated. If it's closer to 0, it gets closer to a circle. Now, you need to know how to calculate eccentricity. Here it is. So, of course, I'm going to do my foci, my c squared first, and then the eccentricity is that c value over a. So, and we're going to do one here in a minute. If I asked you for the eccentricity on this last one, it would be c, 4, 4, 4, over a, my biggest denominator, 5. 5 squared, 25. So it would be 4 over 5. So that's how you would calculate that. So I'm just going to do one more and throw that on you. All right, more of the same. Center, watch your signs, watch your order. What do you got for center? Perfect. So let's just plot that. 2, 1, got it? All right, 25's under x. I'm going to square root that 5. 5 right, 5 left from the center. 1, 2, 3. Okay, 4 under y. It's the square root of 4. 2, so up 2, down 2 from the center. Let's try to draw our oval here. Could be better, could be worse. Okay, vertices. Are they the left and right points or the top and bottom? Left and right on our major axis, our longer axis. So I'm just like, okay, I'm at negative 7, 1, and I'm at 3, 1. How long is the major axis? How wide is it? 10. Move at 5 and 5. How tall is it? 4. 2 up, 2 down. So I'm going to do the foci like normal, and then we're going to add on that eccentricity thing here in a sec. But let's do our foci because we need c squared for both of those. 4 minus 25, 25 minus 4. Which way? Yeah. So square root of 21, which, well, yeah. Now, for me to graph that, okay, I don't know the square root of 21 off the top of my head, obviously. So I punched that one in earlier. It's about 4.6. So from the center, I'm counting 4.6. And remember, ours is horizontal, so I'm going to go left and right 4.6. 2, 3, 4.6. Yeah, maybe. 3, 4.6. Okay. Now, I need exact coordinates of that. I need it with the square root of 21 in it. So here's where it can get a little dicey when your center is not on the origin. Now, they're on the left and right. We counted left and right. So we affected, or we changed the x coordinate of the center. I started at negative 2. I added a root 21, and then I subtracted a root 21. So I'm using the center. So that's an easy way to do it. I'm switching the center because I went left and right, so that's why I put it on the x coordinate. If I would have had them up and down, I'd have -2 and then 1 plus or minus the square root of 21. So you have to use your center to help you write those exact answers. Okay, eccentricity, C over A. We'll see we got square root of 21. A. A is the square root of your biggest denominator. So square root that 5.
Okay, you don't have to do it.
That's all I need from you. Now, if it was 20, square root of 21 could be simplified. I'd need it simplified, clearly. But that's as wild as it gets. Any questions on that guy? All right, 11 ellipse, my friend. Now, here we go. 4, 5, and 6. They're all probability. So, suppose you mix up 6 cards with the letters A, B, C, D, E on them, choosing one without looking. Now, probability. Remember, to calculate probability, it's the favorable outcomes over the total. And remember, you will get the Chapter 8 formula sheet. That is on it. I mean, yeah, okay. Now, I'm going to give you a pro tip. I could stand up here and do a whole lot of work, but let's just make it super, super easy. Probability of not selecting A or E. So that means we're looking at the probability of every other letter. Well, there's 6 total letters. How many of them are not A or E? 4. So 4 out of 6. Now, riddle me this, class. Why would this be like a commonly missed one?
Because you think you're multiplying and I got
Okay. I'm just curious. I'm just like, what? To me, this seems easy. So that's why I like to go over these just to double check. Okay. A drawer contains 12 red socks, 8 white socks, 6 blue socks. Without looking, you draw it, return it, take a second socks. Probability, red and blue. Well, let's do the red first. How many total red socks are there to select from? 12. How many total socks are there? 20. If you add them up, 12 plus 8 plus 6 is 26. Okay, let's do the blue socks. How many total blue socks are there to select from? 6. Now, here's the question of the day. Are you adding those probabilities or multiplying them? Multiplying. And means multiply. It says it on the formula sheet. Yes. All right. I'm just going to tell you what you get. You get 18 over 169. All right. Why do we think this is on the commonly missed? I don't get it. It seems easy to me. Add? You think? I don't know either. They don't read it close? All right, 6. You work at a t-shirt printing business. Of 3,500 t-shirts shipped, 182 are printed improperly. If you randomly choose a t-shirt out of the shipment, what's the probability it's printed correctly? Well, I know there's a total of 3,500 shirts. What's your favorable outcomes? Probability it's printed correctly. How many are printed correctly? Jesse's got 3318, which is right. How did you get it? Yeah. You got to subtract it out to figure out how many are poor. Now, how many are bad shirts? Okay. Now remember, probability, you can give the answers as fractions, which is kind of most common, or percents. You might see a percentage. So kick this to a percent in your calculator for me. What do you got? See if we can make sure we can get percents today. Scares me greatly. All you have to do is divide that. Just straight divide it. 0.8%. I'm getting scared, kids.